In this video, we're going to see how to determine if a set is a basis of a vector space or not. So the key idea here is that we need to check two things to see if something is a basis. We need to check if this set is linearly independent and that it also spans R3. So there's two things to check here. The good news is it's fairly straightforward to check both of these things at the same time. So what we'll do is we'll write down a matrix corresponding to the system where these are on the left-hand side. So that would be the matrix, first column is 2, 1, negative 1, the second column is 3, 1, 4, and the third column is 7, 0, 3. Now if we're thinking about whether this set is linearly independent or not, we would augment with zeros and ask ourselves how many ways are there to build the zero vector. If we're asking if it spans R3 or not, we would augment with an arbitrary vector v and ask ourselves whether we can always find a solution no matter what v is. The answers to both of those questions really only depend on what's going on the left-hand side. So we can go ahead and write down the left-hand side and compute the reduced row echelon form here. So type this into Wolfram alpha, and it has spit out the matrix 1, 0, 0, 0, 1, 0, and 0, 0, 1. All right, so for the first question of linear independence, we want to know if we augment this with zeros, how many solutions do we have? If I augment it with zeros, we notice that the system will look like x1 equals 0, x2 equals 0, and x3 equals 0. So we would only have the trivial solution, which tells us that we're linearly independent. Now, we want to know if this spans R3 or not. So now we want to ask ourselves, no matter what I augment over there, are we going to have a solution or not? And sure enough, no matter what I would augment with over here, it really doesn't matter what ends up over here, our system is still going to look the same. It's going to look like x1 equals whatever's up here, x2 equals whatever is here, and x3 equals whatever is here. So we do always have a solution no matter what happens over there. So we do span R3. So we're linearly independent and we span R3, therefore we are a basis of R3.